Okay, in this example, we got a 3-color spinner, and it's spun. The random variable is the number of points, and that can be a 1, 2, or a 3. So find the probability generating function for this random variable. Well, let's think about what this means. I have the random variable equals x. I could get a 1, a 2, or a 3. And the probability of that occurring, the 1 happens a quarter of the time, 2 is half the time, and 3 is a quarter of the time. And so if I'm going to make my probability generating function, g of t is simply, I'm going to do a 1/4 t to the power 1 plus 1/2 t to the power 2 plus another 1/4 t to the power 3. And there's the generating function for x. Now B part says the spinner is spun twice and the sum of the points are considered. So what that means is I'm going to do x plus x is what I'm looking for. And so to find the generating function, I can use the theorem that we developed last video, this particular one here. When I add the two random variables, I can multiply the generating functions. So what I'm going to do then is I'm going to go, this is equal to generating function of x times x's generating function. I can multiply those together. And so when I do that, I get 1/4 t plus 1/2 t squared plus 1/4 t cubed. And that's going to be, in this case, squared since they're both the same. When I multiply that all out, and I won't go through and do it, but when I multiply it all out, the final answer, and you can try it yourselves if you don't believe me, is going to be 1/16t squared plus 1/4t cubed plus 6/16 t to the 4th plus 1/4 t to the 5 plus 1/16 t to the 6th. Okay, and so now this is the new generating function for the sum of two spins. And C part then says find the probability of the sum being 5. Well, if I want the probability of the sum being 5, I want the probability that x plus x is equal to 5. Well, I use where this is 5, the exponent is 5, refers to specifically the probability of that sum, and I can see quite clearly that the probability is going to be 1/4. So there is a use of the probability generating function. I could have as well, if I wanted to, I could have taken the 5th derivative of the generating function at 0, and that as well, then I would have went 1/n factorial, which is, I know, 5 times the 5th of 0. And that would have found me the probability, that would have found me this particular probability here, would have been that as well.